Welcome back. In this refactored version, we're going to write a better function that can compare any two values of any type, including nested objects like this, right? Distinguishing negative and positive, 0. Nands are true, distinguishes symbol labels as well. And it's actually very, very easy. Okay. So how this is going to work is that we're going to take care of comparing all primitive values first, and then we're going to call the recursive if it's not a primitive values. So let's start. First, I'm going to do val1. If val1 is strictly equal to val2, I'm going to return true. Okay. Now, but remember, we're also comparing negative 0 and 0. In the browser, if you try to compare them, they're actually true, but we want them to return false. Okay? So right here, I'm going to say and you say val1 or val2 not equal to 0. Okay? If they're both are zeros, we're going to handle that later as well. Okay, and then now we're going to check for nan, no, and undefined. Right? So I'm going to say if val1 is double equals to no, or val2 is double equals to no, return false. Okay. What this is doing is it's saying, hey, if both of them are the same type and value and not 0, return true. Okay. This only runs if they're not the same value. So if they're not the same value and neither one of them or either one of them are null or undefined, they're still going to be false. Okay. Okay. So now, how do we take care of nans, numbers, strings, functions, symbols, and all of that stuff? Well, it's actually pretty easy. I'm going to do const myString1, and this is going to take care of strings and number. And you're going to see why I created this string here. So now, since you did that string, you can do something like if myString1 dot includes type of val1, and then you do the same thing for 2, right? Val2, then what are we going to return? We're going to return, well, if we're comparing two types, strings or numbers, then we should return with object.is. Why? Because nan is never equal to itself. But if you use object.is, then your nans can be true, like this. See? So object.is, val1, val2. And object.is works for comparing numbers versus strings as well. Okay, so look how short we actually made this. Okay, so now how do we take care of functions, symbols, and the other stuff? Right. Well, functions actually takes care of also promises and classes, right? Because classes are also functions. Okay, so once again, I'm going to do const myString2, and this is just going to handle functions and symbol. And then we're going to be done. We would have handled every single type already. And you know what? You can literally just copy this, and then you're going to change 2, 2, 2. Oh, type of should be 1 right here. Okay, and then instead of object.is, I'm just going to call this string. So string val1, let's see if that is equal to string val2. Okay, because to compare function expressions, we need to stringify them. Same thing with symbols, right? To determine if they have like a different label, we can stringify them. Okay, and you know what? We are now actually done. We can compare any two primitives now. Let's take care of the objects and the arrays. How do we know if two objects are the same? Well, first, we're going to check if all of their property key names are the same. So const keys1 array is equal to object.keys val1. And then this is going to be 2, and this is going to be key2's array, right? And then I'm going to say if string key1's array, if this is not equal to string keys2 array, then we're going to return false. Okay. So now here's the recursive part. We only run the recursive if they have the exact same property names. So now let's do a for of loop. So const, I'm going to call this key of keys1 ARR. You can also pick keys2 because they're exactly the same, right? Okay. And then inside here, it's going to be an if statement with a logical not operator. So this function is going to call itself. Okay. So it's going to call itself passing in val1 at the current key that we're on, and then val2 at the current key that we're on. Okay. And inside here, if anything inside of this recursive returns false, meaning any of these on top, then the objects are not the same and we return false. And at the end, if nothing returns false, this for loop finishes, we're going to return true. Okay. Let's see, line 23, keys to ARR, like this. Okay. And I think we're actually done. So if you come down here, it says that it's true. Oh, if I change, let's change the name of this class. See, it's false, right? This nested object, if I change this null to, let's say, let's do undefined, see if it can tell the difference. It's false, and then come back here, I change this second null to undefined, it should go back to true. Cool, right? And then let me uncomment all of this down here. So you can see, we can even compare direct arrays as well. See, arrays of the same values return true, of different values return false. It distinguishes negative and positive 0. If I change this 0 back to positive 0, it will say true. Okay, symbols with the same labels are true. Symbols with different labels are false. Now, let's look at something else. Let me do let counter equal to 0. And then down here, I'm just going to say console.log recursive part ran, and then you can just say counter plus plus times. All right, now let's go down here. Let me comment out all of this. And then let's call compare again, passing in obj1, obj2. All right, so in order to find out that everything was true, the recursive part had to run 37 times before it returns true. Okay. But now, what happens if we only mess up, let's say, the key name? See, then it actually ran 0 times. Why? Because it got stopped right here. Okay. So by writing it this way, if the values are primitives, it will take care of that right away. Okay. If the length of the key names or the key names themselves are different, it will also take care of that right away. Only when everything's the same, then it does the internal comparison.